Greetings, welcome to this new video about Kirchhoff's laws, KCL and KVL. Solve the problem number 7. Given the electric circuit with R1 is 1 ohm, R2 4 ohm, R3 8 ohms, R4 2 ohms, and we have two sources. One is voltage source Vs 9 volt and the other one is current source of 5 amps. The question now is to calculate the voltage V1 and the dissipated power in each resistor using Kirchhoff's law. Let's go to solution. Let's start first to the step number 1 is to choose the direction of the current. This is I1 through R1, I2, I3 through a resistor R3, I4 through the resistor R4, and we have I through the voltage source Vs. After we finish step number 1, we go to step number 2 to identify the polarity of each resistor. We know that the current flow always from the high potential to the low potential. That means this is positive and negative of R1, positive and negative of R2, positive and negative of R3, positive and negative of R4. After we finish step 2, we go to step number 3 to apply Kirchhoff's current law, KCL. Let's start first with node A. We can see here that I1 leaving the node, I2 and I2 is entering the node, I1 leaving the node, and IS leaving the node. We can write KCL at A, I2 is equal to I1 plus IS. Let's go now to node B. We see that I entering the node, I3 and I2 leaving the node. That means KCL at B, I is equal to I3 plus I2. We go now to KCL at C. We see that I3 and IS entering the node and I4 leaving the node. We can write IS plus I3 is equal to I4. After we finish applying Kirchhoff's current law KCL, we go now to apply Kirchhoff's voltage law KVL. Before we start applying KVL, we need to choose the different loops we are going to use here. This is loop number 1 and this is loop number 2. We can write KVL in loop 1, negative R1 I1 minus R2 I2 plus Vs is equal to 0. We obtain finally negative I1 minus 4 I2 plus 9 is equal to 0. We go now to loop number 2. We have R3 I3 plus R4 I4 minus Vs is equal to 0. We obtain finally 8 I3 plus 2 I4 minus 9 is equal to 0. After we finish applying KCL and KVL, we obtain 5 equations with 5 unknown. We still only need here to solve those equations in order to obtain I1, I2, I3, I4 and I. Let's start with equation number 3. We have 5 plus I3 is equal to I4. By multiplying 3 by 2, we obtain 2I3 minus 2I4 is equal to negative 10. I will call this A. We have 5 is 9 is equal to 8I3 plus 2I4. If we do A plus 5, we can easily cancel the terms 2I4. Then we obtain finally negative 1 is equal to 10 I3. That means I3 is equal to negative 1 over 10 is equal to negative 0.1 amps. We go back to equation 3. We already found I3. That means I4 is 5 minus I3. I4 is 5 plus I3. We obtain finally I4 is 4 0.9 amps. We have equation 1 is I2 is equal to I1 plus 4, and equation 4 is negative I1 minus 4 I2 plus 9. We can see here I1 and here negative I1. We can easily here cancel I1 by using or by adding 1 plus 4. We obtain finally 5 I2 is equal to 14. That means I2 is 14 over 5 is equal to 0.8 amps. We go now to equation 1. We have I2 is equal to I1 plus 5. We already found I2. We can easily calculate I1 is equal to negative 2.2 amps. Finally, we have I is equal to I2 plus I3. That means I is equal to I3 is negative 0.1 amps and I2 is 2.8 amps. We obtain I 2.7 amps. After we finish calculating the currents, we can deduce the voltage V1 is equal to R1 multiplied by I1 is equal to 1 multiplied by negative 2.2. We obtain negative 2.2 volt. This is the dissipated power in the resistor R1. R is equal to R1 I1 square is equal to 484 watt. This is dissipated power in the resistor R2 is equal to 31.36 watt, and this is dissipated power in the resistor R3 is equal to 0.08 watt or 80 milliwatt, and finally the dissipated power in resistor R4 is equal to 48.02 watt. After we finish calculation, we verified our calculation using SPICE simulation. Let's go take a look in the SPICE simulator. Here is the circuits done by SPICE simulator. Let's go here to analysis. We do analysis, calculate nodal voltage. We can see here this is the voltage V1, negative 2.2 volt, and this is our the wattmeter 1, 2, 3 in order to measure the dissipated power in each resistor. We can see here P1 is 484 watt, P2 is 31.36 watt, P3 is 80 milliwatt, and finally P4 is 48.02 watt. Is exactly the same value we have obtained by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will reply you as soon as possible. Thank you for watching. Have a nice day. Bye bye.